We're going to go ahead and take a look at number 23 from section 1.4, which is applications of quadratic equations. Again, please make sure that you have your textbook in front of you so that you're able to read it along with me. I would also suggest that you have a sheet of paper and pencil out in front of you, because as I'm reading, I would suggest that you jot down the pieces of information that you feel are the most important to help you solve that problem. So, number 23. The height of a projectile fired upward with an initial velocity of 400 feet per second is given by the formula h is equal to negative 16t squared plus 400t, where h is the height in feet and t is the time in seconds. We want to find the time required for the projectile to return to Earth. So maybe with this one, what may have posed a bit of a challenge was that they weren't very direct in their wording. They are direct in what they want you to do, but they are saying in this case, they want you to find the time, but they want you to find the time when the object returns to Earth. In other words, when the object lands back on the ground. So if the object is returning to the ground, what height would it be at once it connects to the ground? If you're saying, okay, well, it wouldn't have a height, it's reached the ground, so it would be at 0, in this case feet, because that's what the units for h are. So in this case then, that's what we would say. I know that the height is going to be 0. And this is going to then be equal to negative 16t squared plus 400 times t. Okay? So now we have to solve for t. So what you can do here is you could default to using your quadratic formula program in your calculator, or you could just use the quadratic formula in this case. Notice here that if you were to do that, your A would be negative 16, your B would be positive 400, and you might be saying, okay, but I don't have a C. Well, technically you do. You just can't see it because C in this case is 0. Okay. So if you wish to use the quadratic formula to help you with this, that's perfectly fine. I'm going to show you a bit of a different way. Because I actually don't have a C or a constant value, or I mean it's 0, I can actually get a little bit more creative. So let me rewrite the line. I have 0 is equal to negative 16t squared plus 400t. We'll take a look at the right-hand side. I note here that there is a common factor of t that is happening here. So I'm going to factor out a t, and then I can use what is called the zero product property. So we've kind of discussed this in class. If we know that t times this quantity of negative 16t plus 400 equals 0, what can we conclude? Well, we could say that either t is equal to 0 or negative 16t plus 400 equals 0. And this kind of solves itself relatively quickly, because here's what we can do now. Well, I know that t equaling 0 makes sense, so we would say, well, at 0 seconds this projectile is on the ground, but that doesn't quite make sense for this problem because we've launched it, so some time must have passed from the point of launching this object into the air and it landing. So t equaling 0 seconds doesn't make sense for this particular problem. So our answer is going to lie within our second equation. So what we will do here in this case, we will subtract 400 from both sides to clear it on the left-hand side. And we have negative 16 times t is equal to negative 400. Well, at this point, it's pretty light. We want to hit it with the inverse of division here to break up that multiplication that's happening. And then we will get t is equal to 25. And remember, our units are seconds. So that makes a little bit more sense. So from the point of launching this projectile into the air, it's taken 25 seconds for it to make its arc up into the air and then come back to Earth. So there is your solution. If you have any additional questions, please feel free, or if you feel that this explanation wasn't clear, please feel free to either email me or come see me directly. I'd be more than happy to help you out.